All right. Hi, everybody. This is Objective 3.1 again. I can prove and apply theorems about triangles. So yeah, 3.1 has 2 lessons. This is the second one. Yeah, so just some more stuff that we need to know about triangles. So let's start with important vocab. Supplementary means adds up to 180 degrees. Adjacent means next to. And in geometry, we use that word a lot with angles, where if we've got one angle and then we like smash another angle like next to it, right here, so they like share that side, we call those adjacent. A linear pair is a set of adjacent angles that form a line together. So like, again, angles are connected here and then they form a straight line here. And then these angles are supplementary, they add up to 180. Interior is a fancy way of saying inside. Exterior is a fancy way of saying outside. And then remote is, we use this word to say like a far distance, like far from something. Cool. So we're going to talk about 2 things. The first is the triangle sum theorem, and in class we did a little activity to like discover what that is. I'm going to sum up what we discovered here in our key points box. So what we discovered is the triangle sum theorem says the sum of the measures of the angles in the interior of a triangle is 180 degrees. So the 3 angles inside a triangle will always add up to 180 degrees. And I'll show you why. So like here's a way we can actually like prove that's true. So if you consider the figure below containing a triangle and parallel lines. So these lines, you see these symbols on them. So these parallel lines are right here, right? Use what you know about straight angles and parallel lines. Determine the sum of the measures of the interior angles of a triangle. So my triangle is here, right? And let's notice something. Now the top and the bottom of a triangle will always be parallel to each other. So that's why we're like able to like connect these lines at the top and the bottom of a triangle. And then look, one side acts as a transversal, right? So I've got a transversal here. And let's fill in some stuff we know to be true about transversals that intersect parallel lines. Well, I'm noticing here are alternate interior angles. Alternate interior angles are congruent when a transversal intersects parallel lines. So if this is A, then that's A. Okay? And then if I look over here, I see another transversal. Okay, so over here is another transversal where again, I see alternate interior lines, and alternate interior angles are congruent when a transversal intersects parallel lines. So that I can also call C, because these are the same. I can use congruency markings too. I get to use the same variable. So, sweet. So now I'm noticing A, B, and C in two different places. Let's focus on this A, B, and C first. Oh, I'm noticing these A, B, and C are all on that line together, right? The measure of C, B, and A is there. That forms a half circle, so worth 180 degrees. So A, B, and C would add up to 180 degrees. Well, that same A, B, and C is inside the triangle now because of what we talked about with transversals. So, that's a way to kind of prove and know for sure that the angles inside a triangle will always add up to 180 degrees, okay? So, that was a lot. Hope you feel good about it. Yeah, hey. Just want to say hey, I'm wishing you love and power. Okay, so, this is useful. Like, let's say we have like this picture of this triangle, right? And, we want to find the value of x. So, what we can do here is set up an equation where this angle plus this angle plus this angle will add up to 180 degrees. So we'll know that 5x plus 4 plus 52 plus 74 is going to equal 180 degrees. Let's do that math quick. So 52 plus 74 is 126. Oh, plus 4 is 130. So we have 5x equals 5x plus 130 is going to equal 180. 180 minus 130 is 50. And so I think I did something wrong. Hold on. 52 plus 74 plus, oh, it's 62, not 52. My bad. Right? That's a 6. Yep, 62. Just kidding. That's 188. Wait, sorry guys, I think I'm messing this up. 5x plus 4 plus 62 plus 74. Yeah, so, oh, okay. So, sorry, I'm adding these up now. 62 plus 74 plus 4 is 140. What am I doing, guys? I'm sorry. Ooh. Okay, here we go. Now, subtract my 140. Subtract my 140 from both sides. 40 equals 5x, divide by 5, and you get x equals 8. Yeah. Okay? That's one way of figuring this out. Another way is if we added these two angles together, 74 plus 62 is 136. So then I could find this angle by doing 180 minus 136, because I know those three angles have to add up to 180. So that makes that angle measure worth 44 degrees. So if I want x, I could also set 5x plus 4 equal to 44 degrees, and then solve the equation that way. Get 40 equals 5x. Just solving this quick. Mother of God, just really pencil. This example and I are struggling. Okay, divide by 5, we get x equals 8 again. So two different ways to deal with that, okay? Cool, and then we got some light practice problems. Then we're going to jump to our second key points box. This has to do with another theorem about triangles called the exterior angle theorem. And again, we did a thing in class. We're going to skip over that for now. And I'm just going to tell you that the exterior angle theorem is when the measure of the exterior angle of a triangle. So if we have a triangle and we extend one of the sides to form this an exterior angle, which happens all the time. Think about patterns that when triangles are squished together, there are exterior angles outside all the time. So the measure of this exterior angle is equal to the sum of the measure of the two remote interior angles of the triangle. So these two angles. Now, I'll show you why that has to be true in a second, but basically what this theorem says is that I've got these two remote angles, right? And then this exterior angle. To find the measure of the exterior angle, I can just add a plus b, and that equals d. A plus b equals whatever d is. Okay? And I'll show you why that works over here. So if we're finding the measure of the missing angle over here, so one way I could do it is remember my triangle sum theorem, right? So 46 plus 75 is 121. Okay? So then I could subtract 180 minus 121 to find this angle. And get 59 degrees, right? And then to find that outside exterior angle, I could notice that this is my exterior angle, right? Notice though, connected here, a linear pair gets formed. So they add to 180, so I can do 180 here. So to find this angle, I can do 180 minus 59. And I get 121 again, right? Now, that is the same as when I just added these two remote angles, interior angles, right? And that's because the sum of this is always going to be supplementary to 59. The exterior angle is also always going to be supplementary to 59. Hi, I'm recording a video. So that's why this will always work, okay? The fast way to do it is just, there's nothing wrong with the math that I did, but the fastest way to do it is just 46 plus 75 gets you to 121 for that exterior angle. Okay? Hi guys, I'm recording a video, so I can't chat, okay? I just need like 2 more minutes. It won't let me pause. Okay, so if I'm looking at example 4, and we're finding the measure of the missing angle, and I want, okay, so now this is in here, right? And again, I could go like the long way. I could like use this 91, there's a linear pair again here, I could fill this in, and then do triangle sum theorem. Or I could remember that, okay, these are my 2 remote interior angles, those 2 angles inside. This is my exterior angle. The sum of these 2 angles, so 65 plus, let's call it x, because we don't know what it is going to equal 91. So all I have to do here is like solve this little equation, get 91 minus 65 is 26 degrees. Cool. Okay, one more example. Oh man, variables. So we're trying to find the value of x here. So I've got these 3 angles. Now, doing triangle sum theorem to find the measure of this angle, right, won't work because this is a variable. I don't know the measure of this angle, okay? I also can't find the measure of this angle using the linear pair that I see here because, again, I don't know the measure of this angle. So I'm going to have to set up an equation. So remember, I'll be done in like 2 seconds, guys. Okay, I got an exterior angle here, right? And then I have these 2 remote angles, right, that aren't touching that angle over here. Well, the sum of those 2 remote angles is going to equal my exterior angle by this guy, right? It's going to equal my outside angle. So like these 2 remote angles inside are the sum of them is going to equal the exterior angle. So that's what, like, just kind of a setup of an equation where I can be like, oh, 42 degrees plus 5x plus 16 degrees equals 10x minus 2 degrees. And then I can just solve this equation, right? So 42 plus 16 is 58. So I get 5x equals 58 equals 10x minus 2. All right, let's get my numbers to one side and my x to the other side. I'm sorry, that's a plus sign. Bam. I'm going to get my numbers over here and then my variables to the right. So I'm going to get 5x equals 60. Divide by 5, divide by 5, and you get x equals 12. Okay, sorry, the solving there was fast, but what really matters is the setup of the equation. Okay? That's it. Hope you have a good rest of your day. Good job. See ya.